Hello, in this video we will know about the DC or direct current and AC or alternating current, also the difference between them. The devices we use in our home like the mobile phone charger, laptop's power adapter convert the AC power to DC power, then they will charge the devices. It means yes, the power we get into our homes is AC power supply. But depending on the function and the type, the devices first take the AC supply into them and they convert the AC supply to DC supply, such as mobile phone chargers, laptop power adapters, LED bulbs such as LED, televisions. Of course, in televisions, some parts require AC power, so they use AC power. But most of the parts in television use DC power, which is converted from AC to DC. Or the devices directly use the incoming AC power, such as ceiling fans, refrigerators, iron boxes, and some type of light bulbs, such as incandescent bulbs, fluorescent bulbs. The direct current or DC has the electrons to pass only in one direction within the conductors. That's why it's called as direct current. And direct current is represented with the symbol straight line and some dotted lines beneath it. The alternating current or AC has the electrons to pass back and forth many times for every second. That's why it's called as alternating current because the current is flow of electrons and electrons alter their way. Since the current is alternating, it has some frequency. Like in power lines in USA, Canada, frequency is 60 Hz with 120 volts at the households. It means the electrons flow back and forth 60 times every second in the power lines. In the power lines of UK and many other countries, the frequency is 50 Hz to 30 volts at the households, which means you might have already guessed the electrons flow back and forth every second 50 times. So the alternating current has the sine wave, which indicates for each sine wave 1 hertz of frequency, which is 360 degrees per cycle. Also, so the AC power is indicated with a straight line and a sine wave beneath it, or only a sine wave. As we can see, the current changes the direction, and the sine wave represents that. The voltage actually increases and decreases in the alternating current. Also, the direction of the current changes. It means here, for example, 230 volts and 50 hertz supply, the voltage undergoes 0 to 230 volts in positive peak and comes back to 0 and goes to negative peak 230 volts and comes back to 0. Completed one cycle or 1 hertz and again the second cycle starts from there. This happens 50 times in a second, which is 50 hertz or 50 cycles. Starting from generation stations, the AC power is generated and stepped up using the step-up transformers to minimize the losses during the transmission of power. Then the transmission lines carry the power to long distances, and when it comes to your local substation, it is stepped down and delivered to the distribution transformers. The distribution transformers distribute the AC power after further stepping down the power to 230 volts or 120 volts, and it comes to your household through service mains. Then the devices plugged to the switchboard either use the AC after converting it to the DC, or they directly use the AC depending on the type and requirement in the parts of the equipment. The batteries can only store the DC power. If you look at the inverters, when they charge the battery connected to it, it first converts the AC to DC. Then, when the power in the battery needs to be used, the inverter converts the DC to AC and supplies it to the whole home. The DC doesn't have any frequency because it only flows in one direction. You may be wondering why the direct current was not converted right after the alternating current was generated and passed it all the way along the homes, offices, buildings, etc. This has not happened because by passing the direct current over long distances, several line losses can occur, such as reduction of current as the line gets longer, heating up of lines, etc. But in AC, these losses are minimized. Hope you got to know about alternating current and direct current and differences between them. Thank you for watching this video.